फ्रेंड्स, डॉक्टर अशोक जी मैक सॉल्यूशंस में आपका स्वागत है। टुडे व्हाट वी आर गोइंग टू डिस्कस बेसिक concept of the engineering mechanics. So what is the engineering mechanics? Before going to the subject, we have to know the definition of the engineering mechanics. So engineering mechanics is nothing but branch of physical science which deals with the study of the forces and its effect on the body. That should be either body should be in rest conditions or body should be in motion. Now you see effect. Effect meaning what? It's the effect of the body. Two types of effect will be there on the body: internal effect and external effect. Internal effect we will study in the SOM, strength of material. External effect will be a study in the engineering mechanics. First you are going to see the what is the external effect. Suppose one block is there. We are applying the force and we are providing the support. We are providing the support. So what will happen? Body will be the static condition. Here total force will be zero. If we will remove the support, what will happen? If we remove the support and apply the force, body will move either velocity, acceleration, displacement. So this, what is the velocity changes, what is the acceleration changes, what is the displacement will the body, that will study in the external effect. Okay, what is the internal effect? Just basic little I will discuss. Suppose you are applying the force in the body, what will happen? Suppose you are providing the support. So internal displacement will be the internal atoms, all lot of atoms will be, they will get the displaced. So suppose you want to see the what happening inside the body, you cut the section, like these sections will come. Now you see this effect will be there, like some small displacement will be there. So these are the internal effects. So internal effect will study about the stress and strain. What is the changes of the stress? What is changes of the strain? So these things will study in the strength of material. And external effect will study in the engineering mechanics. So before going to the subject, we know that what is the classification of the engineering mechanics. Engineering mechanics are classified in two types: mechanics of solid and mechanics of the fluid. So fluid mechanics again is the different subject where we will study about the fluid, either fluid is in rest or in motion. Fluid if you will tell na, that is the liquid and gases will be the fluid. So this is the different subject. Fluid mechanics student will study. Now our subject engineering mechanics will come to our area. Solid mechanics we have two types. Mechanics of the rigid body and mechanics of the deformable body. So rigid body, what is meaning of rigid body? It does not deform under the action of the applied force. That is called rigid body. Actually speaking, you cannot see the body will be the rigid. Generally all the body will be the deformable body, but for engineering mechanics we are assuming body is a rigid body. Suppose one example I will give. Suppose one truss will be there. Truss is there. PQR one truss will be there. Apply the load. Due to this load, P kilonewton, or we already taken F kilonewton. Now, due to this bar PQ, PR, some displacement will be there. But if we assume rigid body, then only we can find out what is the force sharing PQ, PR and QR. If we assume this is deformable body, we cannot find out. But actually practice what is, suppose force applying, so definitely some deformations will be there. Little deformations will be there. So if we not assume this rigid body, we cannot find out the force applied in this bar PQ and PR. So but once we have to solve the question, we have to assume this in the engineering mechanics of the rigid body should be rigid. But mechanics of the deformable body, if this will study the strength of material where body will deform under the action of the applied forces. Now mechanics of the rigid body we have two types: statics and dynamics. So what is the definition of the statics? It is the subject which deals with the system of body is in rest. If you will go the dynamics, everything will be same. It is the subject deals with the system of body at rest. This is called statics. Is in motion. The body is in motion. It is called dynamics. So again, dynamics we have two types: kinetics and kinematics. Kinetics, again you have to, how you define it? Is the subject which deals with the system of body is in motion with external forces. If you will go the kinetics, how you will define? It is the subject which deals with the system of body is in motion without applying the external forces. Without applying the external forces. So kinetics and kinematics both are the parts of the dynamics. So with external force, without external force, I wrote, you have to include these definitions only. So again, you listen, statics, it is the subject which deals with the system of body is in rest. If dynamics, system of body is in motion. If you are coming kinetics, system body is in motion, system of body is in motion with external force or with applied the external force. Kinematics without apply the external forces. So these are the classification of the engineering mechanics. Now what is the application of the engineering mechanics? So if you see the many projects, many civil construction field, many projects you will see the applications will be there like spacecraft, something there was written, spacecraft, rocket, structure, stability, vibrations, automotive control, robotics, also effective planning, innovative design. All those things they have the application. Okay. Now, before going the subject, we have to discuss the unit and dimension. We have to discuss the unit and dimensions. So dimensions, if you see, dimensions is the quantitative and unit is the qualitative. What is meaning of this? Here I wrote, dimension is qualitative and unit are quantitative. If you consider one room, if you are the room, once you will ask what is the dimension of this room. That means you are talking about the length and breadth. If units, that is called 6 meter, this is called 3 meter. That's called units. So that's why dimensions will be the qualitative and unit will be the quantity. So now we'll do the unit and dimension. So what are the basic units? Basic units you can say mass, then length and time. These are the basic. Mass unit is kg, dimension from like m, length unit is meter, dimension from like L, time unit is t, time unit is second, and dimension formula is t. So MLT system. So these three are the basic concept of the units. Now if we'll go distance, displacement, displacement. So what is distance, what is displacement? Distance, suppose you just draw one line, one person is standing here, he reached the x meter, What is the distance travel? X meter. What is displacement travel? You can say this is x meter. But once this person again come back to the same point, what is the distance travel? X plus x, 2x will be there. X plus x, 2x. But what is displacement? Displacement will be 0. So distance is scalar quantity, displacement is the vector quantity. So now suppose we will write now what is the velocity, what is the speed. So velocity nothing but displacement per unit time. Speed is called distance per unit time. Distance per unit time. What is unit of the displacement? Already told you are going one point to another point, that means you are traveling some distance. No? So that's the displacement, changing the place, meter. Time is second. Distance also meter. Time is second. What is dimension formula? L by T. That is known as LT minus 1. Here also same, L by T, that is LT minus 1. So velocity, displacement per unit time is known as velocity. Unit is meter per second. Dimension formula is LT minus 1. Speed will be distance per unit time. So same dimensional formula. But here, what is difference between velocity and speed? Velocity is scalar velocity is vector quantity, and this is scalar quantity. Similarly, displacement is a vector quantity, distance is a scalar quantity. Now we'll go little bigger units. Suppose say acceleration. Accelerations, now how we'll define, how we'll analyze this? Velocity per unit time. Velocity per unit time is known as acceleration. Now what is the unit? You know already velocity unit is meter per second and time unit is second. So meter per second square. Then how will we write the dimension formula? Because already basic we have studied. Meter, L, time, T square. So LT minus 2. So acceleration unit will be LT minus 2. Now it will go force. First you analyze the force. Force nothing but what is? Mass into acceleration. Mass into acceleration. Mass is unit is kg. Acceleration unit is meter per second square. So 1 kg meter per second square known as 1 Newton. 1 kg meter per second square known as Newton. Then how will write the dimension formula? Unit will be kg meter per second square or Newton. Dimension formula how will write? Kg na mass, m is L, s square means t square. So ml t minus 2. This is unit of the force. So you see, gradually we are knowing the basic units, small units, then acceleration, mass. Gradually once you are going, you are seeing the bigger values, bigger dimensional formula. Suppose now you think about power. So power unit means watt. Power unit means watt. Watt also you can say joule per second. You have to analyze. If you analyze, then only you can write the dimensional formula. Because why we are discussing this, one questions will come. I write the unit and dimensions of the particular terms. So power joule per second. Again, joule nothing but Newton meter. So two things you now you saw here. Kg meter per second square is equal to Newton. 1 joule is equal to 1 Newton meter. You have to remember for the analyzing the formula. So joule nothing but Newton meter second. Now Newtons you know force. So ml t minus 2. Then meter L. The second t. So what will be there here? M L square t minus 3. So again you check it. Joule per second. Power, you are analyzing the watt. Joule na Newton meter. Second. Newton na MLT minus 2. Second na T. And meter L. So ML square T minus 3. This is unit. It is the dimensional formula for the power. Suppose you want to write work done. What is the work done formula? Work done unit? Joule or kilojoule. So kilo, we are not kilo, when bigger value will be there also. Bigger value na, then we are writing for kilojoule, megajoule, but unit will be joule. Work done unit will be joule. Also you can write the Newton meter. Also you can write Newton because this is the analysis for this. Now Newton means what is? ML t minus 2 and L. So what will be the ML square t minus 2. So what we are observing here, once bigger terms will come like force, like power, like work done, like energy, like stress, strain, Young modulus. Like this term will come now, we have to analyze first. After analyzing, we will substituting the basic concept and we can get the dimensional formula for the bigger terms. So like these terms now you cannot remember. You have to analyze and you can write. Suppose we will take another is we are taking Young modulus. Young modulus. What is Young modulus formula? Stress by strain. Stress by strain. Now stress, how you will analyze the stress? Force per unit area. Then actually force per unit internal area. Then strain, change in length to the original length. Change in length to the original length. So if separately you can see stress, force per unit area. Now you know force Newton. Newton what is MLT minus 2. MLT minus 2. Suppose first time you are writing force na, you will write here like mass into acceleration. Mass into acceleration by area. Mass m, acceleration LT minus 2. That also you don't know, then you will see the velocity per unit time. Velocity LT minus 1 by T, LT minus 2. So ML T minus 2. Then area L square. So what will come? M L minus 1 T minus 2. What is this unit for this? The dimension formula is stress unit is Newton meter square. Stress unit will be force na Newton, area is meter square. So Newton meter square unit, dimension formula is MLT minus 2. Then what is unit of the strength? Unit of the strength. So you are seeing here change in length to the original length. So both meter and meter. So no unit. You can say no unit. Then what will be the dimensional formula? Dimensional formula you can write MLT 0, 0, 0. So you can write this way. Dimensional formula M0, L0, T0. Because anything power 1. Anything power 0, not 1. Anything power 0 value is 1. So strength formula, what we can write dimension formula? M0, L0, T0. So this purpose to study this unit and dimension, basic units you can analyze, you can substitute these bigger terms and you can analyze and you can write the unit and dimension. So whatever once you are studying further, bigger units, some units will come, just analyze and try to write the dimension formula. Okay? Okay, students, we'll meet the next video.